Hi guys, let's try to do this list problem today on Leetcode. The problem number is 206, so that's 206 reverse linked list. It says reverse a singly linked list. Examples he gives is 1, 2, 3, 4, 5, and it becomes 5, 4, 3, 2, 1, and the end of the list can be seen by the null pointer in the end. So, and then it says follow up, a linked list can be reversed either iteratively or recursively. Could you implement both? So now that's the interesting one. I'm not sure I'm going to try the recursive one today, but let's give it a shot to at least the regular type of um, a typical reverse linked list question that is seen many times in the embedded systems interviews. So let us first, what we would do is, because it's just my being a lazy person, I don't like to type long type names. So let's call the struct list node as the node type def. So use the type def, and let's call it this. And then what we would do is um, so now one more thing, I'm trying to use C, which I should have actually said in the beginning of the video. If you guys trying to do this in Python or something, then I guess you could do that too. But right now, let's do it in C. So in C, the way it works is you start by defining the variables. It's not like Python, which is dynamically typed. You have to declare every variable. So node, and then you start by having 3 pointers and next. So once you have that, then you say temp equal to head. And what is the strategy here? So let's try to see what we're going to do here. So let's take, you have a linked list like this, and then you have another node here, and then let's say you have a null pointer here. It's a weird way to make a null pointer, but bear with me. So here we are, and now, so these are all the pointers. So if you're going to reverse the linked list, how are you going to do that? You're going to do that by changing these links and making them. So for example, if you start at this node, let's start with the node here. Suppose we are somewhere over here and you want to reverse. What does reverse means? That means instead of pointing to that node, instead of this A pointing at B, which you are seeing here in the current situation, it's other way around. Basically, it becomes more like this. So B is pointing to A. So how can we do this in a iterative fashion and still come out successfully? So that can be done by, imagine your temp here. This is temp in the beginning. Now how we go about pointing these in a way where they start pointing backwards. So when we start with temp equal to head, and we say while temp, uh, first thing we do is, because you see we have to keep walking the list. So if I change the temp next here right now, suppose I say temp next equal to prep, what is the problem with that statement? It looks very good because that's what we are trying to do. This temp next was here and the prep. So first of all, we have to also initialize prep. Prep has to be initialized to null pointer. So it looks very good that, yeah, okay, yeah, A has to now point to null because that would be the new end of the list. But what is the problem with this? Now how do we go to B now? We already overwrote temp next, right? So first thing we need to do is we need to save the temp next. So next equal to temp next. So now we know how to go to the next node in the list. And now we overrode this. We said, and then we say prep. Now it's easy. We just move prep to one step ahead, which is the temp current node. And if you guys like to call this temp as current, I'm fine with that. If that's what makes the code much cleaner, Usually I like to call the current as temp in linked list traversals. So prev equal to temp. Now prev has, and now temp moves to the next node which we saved already in next, and that should basically do the job. And in the end, what would have happened? This the In the end, whatever the prev is, because and the temp would be null, so we would come out of it. But prev will be the new head of the list, so we have to return prev basically, and that should do the job. But on the other hand, we can have one more check here. I wonder if you need a check saying if head is null. If you pass a null head, what will happen? We will never even go here while temp, and then we will say return prev. Prev is null, so it doesn't actually us any harm. But probably we would have had a check here saying if not had, then return. I wonder if that is required. But I guess in C, it's always a good idea to do this null pointer check. In any function where you're passing pointers, it's good to do a null pointer check. So let's run this code. Okay, so we have forgotten to remove this thing that I wrote here, but maybe we can comment that out. That might be a good idea. So let's run it now. Okay, so that has worked, and now let's try to submit, and that has worked as well. So things are looking good, but now let's see if we can have a maybe in the next video we'll talk about the recursive implementation of this. If you had to do this recursively, how shall we do it? Basically we have to pass this function again. Basically we have to call this function traverse list with the next pointer and that way we can